In our previous lecture, we have learned about what is NLP, tasks and applications of NLP, challenges of NLP. In this video, we'll learn about basics of NLP using Python code. We'll cover topics like case conversion, tokenization, removing accent text, removing special characters, and expanding contraction. Before we go into the details, we'll talk about an use case of NLP. Let's say we got a project to develop a news website and we would get these news articles from journalists or writers. And now our objective is to categorize these news articles into one of the classes, such as entertainment, politics, sports, etc. So, how we are going to make a computer to process this news article? So, for that, we would be using Python programming language and few libraries of Python, such as NLTK, to process this text. Okay, let's start with case conversion. Okay, let's start with case conversion. Let's take sample text. Let's convert this text into lowercase by using a function called lower. Now let's convert this text into uppercase by using a function upper. If we want to convert this case into camel case or the title case, we have a function in Python called type. Now let's install few dependencies of NLTK. Let me copy and paste the import statement of NLTK, where we can see that we are going to download the machine learning models like predefined machine learning models of Punk, WordNet, Stopward, and average percentage perceptron tagger. Now let's look at tokenization. Take a sample text. Now let's try to split this whole text into sentences by using split function of Python. And we can do that by splitting the whole text by using the delimiter full stop to to split the whole text into sentence. Yes. But the issue here is that as we have split the text by using the delimiter full stop, we have seen that the whole text has been split wherever the full stop is there. But the tricky part here is that we see that the text got delim separated out at every dot, here in this case at the digit. So to improve this, like to improve the model, NLTK has got some predefined sentence tokenizing model which are able to split the given text accurately. Use the method. mm, yes. Here we can see that the sentences got separated out accurately by using the send tokenized method of NLTK. And similarly, if we want to uh, separate all the words which are nothing but tokens in our case, like in the context of NLP, uh, by using simple Python function, we can use split by using space delimiter to separate, like, to get the tokens from the given text. That's right. Yeah. Here we can see that words like we don't want tokens like words with apostrophe s. We want word as a separate token and apostrophe s as a separate token. And also here we have at summit we have delimiters or special characters like quotations. We want them to separate out as a token. For this, we have a function in NLTK to tokenize to get all the tokens from the given text called word tokenize. Here you can see that the tokens like world and apostrophe s, and even here we got special characters separated out by using the function word tokenize. This word tokenize contains in the backend, it contains all the predefined models or the rules that those were developed to developed to consider all of these cases while tokenization. Yes, let's look at removing accent text. Here, let me copy and paste a function that does remove the accented characters. Let's take a sample example of accent text. So what this function does is that we are first normalizing the text into NFKD encoding, and then we are encoding it into ASCII, and finally decoding it to UTF-8. Let's run this function, remove accented text. Yes. Now we can see that all the accented characters have been removed. Now let's look at removing special characters, numbers, and symbols. Let me copy and paste a method that does this. Here, this method removes special characters, takes an input text where it uses regular expressions of Python language to remove the letters as well as the digits. Okay. Uh, Take a text. So this was fun. See you at 7:30. And here we are expecting to remove the special characters like exclamation and all the remaining special characters. And along with this, we have given an argument remove digit. If we give remove digit as true, we expect the digits like 7:30 would be removed. Okay, let's run this function on this text. So we have seen that all special characters have been removed. Let's try to remove digits as well. So now we can see that all the special characters along with the digits have been removed from the given text. Now let's look at expanding the contraction. Contractions are nothing but shorthand notation that we use in English language. For example, um, I would, or uh, so for this, uh, within NLP or within the Python programming language, we have a couple of libraries that does this expanding the contraction. We'll first install the dependencies. So here in this case, we have installed the libraries, contractions, and texts, which actually does this expanding contractions for us. Let's import the contractions and let's see what exactly this contractions library gives us. So this library does contain a dictionary with all the mapping from contraction or the contracted text to the expanded text. For example, here we can see I have, I will, etc. So now let's run method of contraction on a text. Yes. Okay. So we don't see any contract over there. So let's take this text and going for Go for lunch. Let's see if it really works. Yeah. So here we can see that the contraction am has been expanded to I am, and gotta has been expanded to got to. So I am got to go for lunch. I got to go for lunch. Maybe. Yeah. So this is all for this. This is all the scope of this video. In our next class, we'll talk about stemming and lemmatization. Thank you.